Hello everyone and welcome back to this session. Today we are deeping into a fundamental and incredible powerful concept in Java programming, Java Database Connectivity or JDBC. This rough overview a solid understanding of how Java applications communicate with databases, a skill that's absolutely crucial for developing data-driven applications. Whether you are building web applications, enterprise solutions, or even just a desktop, JDBC is the backbone that allows your Java code to interact seamlessly with various database systems. We will explore its core components, understand its architecture, and walk through the essential steps to get your Java applications talking to databases effectively. By the end of this tutorial, you will have a clear roadmap for connecting Java with databases, enabling you to build more dynamic and functional software. The agenda slide listening what is JDBC, architecture, drivers, create, read, update, delete operations, transactions, best practices. Finally, we will wrap up with essential best practices for using Java database connectivity, helping you write efficient, secure, and maintainable code. Each of those topics is critical for anyone looking to master Java database programming, and we will break them down step by step to ensure clarity. Prepare to gain a comprehensive understanding of Java database connectivity from its foundational concepts to advanced usage patterns. What is JDBC? Anyway, showing Java connected to database or JDBC. So let's start with the most basic question. What exactly is JDBC? JDBC, which stands for Java Database Connectivity, is a powerful Java application. Think of an application as a set of rules and tools that allows different software components to communicate with each other. In the case of JDBC, its primary role is to enable Java applications to connect it to execute SQL statements against various relational databases. This means your Java program can interact with the popular databases like MySQL, Oracle, SQL Server, and many more, all through a standardized interface. Before JDBC, connecting Java to databases. Each database required its own unique way of interaction. JDBC changed that by providing a consistent approach. It abstracts away the complexities of different database systems, allowing developers to write database agnostic code as much as possible. This portability is an advantage as it means you can often switch between database systems with minimal changes to your Java code. Importance of JDBC. Building on your understanding of what JDBC is, let's talk about its importance. JDBC as a crucial layer between your Java application and the underlying database. Its primary significance lies in the fact that it enables Java to work seamlessly with databases. Without JDBC, Java applications would struggle to perform essential database operations like storing, retrieving, updating, or deleting data. Furthermore, a key advantage of JDBC is its platform independence. This means that a Java application written using JDBC can connect to a wide array of databases, regardless of the operating system or hardware on which the application or database is running. The diagram clearly shows how your application interacts with the JDBC application. The JDBC driver manager to communicate with specific JDBC drivers for different database systems like SQL Server, Oracle, or any other data source. This modular design ensures that the core logic of your Java application remains decoupled from the specific database implementation details, making your application highly flexible and adaptable to different environments. This is a cornerstone of Java's write once, run anywhere philosophy applied to database interactions. JDBC architecture. Now let's explore the fundamental architectures of JDBC, which are typically categorized into two main types, the two-tier model and the three-tier model. Starting with the two-tier JDBC architecture, also known as the client-server configuration, it's the more basic of the two. In this setup, your Java application acting as the client communicates directly with the data source or database management system. The JDBC driver plays a crucial role here, establishing the direct connection between your application and the database. Essentially, the user machine functions as the client, while the machines hosting the database act as the server. This model is straightforward and often used for similar applications where direct communication is insufficient. Moving on to the three-tier model, this architecture introduces an intermediate layer, making it a more complex. Here, user queries from the client, perhaps a Java applet or HTML server, are first sent to a middle tier, typically an application server running in Java. This application server then processes the queries and executes them against the data server using JDBC. The middle tier can provide services like connection polling, transaction management, and business logic, abstracting the database interaction from the client and enhancing scalability and security. This layered approach is common in enterprise applications. Types of JDBC drivers. One of the most crucial components of JDBC is the driver. Drivers are specific software components that translate JDBC calls into the database specific protocols. There are four main types of JDBC drivers, each with its own characteristics and use cases. First, we have type 1, the JDBC ODBC bridge driver. These drivers act as a bridge, translating JDBC calls into ODBC calls, which then communicate with the database. While it allowed earlier Java applications to connect to a wide range of databases, also existing ODBC drivers. It's generally not recommended for new development due to a performance overhead and dependence on ODBC configuration. Next is type 2, the native application driver. This driver converts JDBC calls into the native application calls of the database. For example, an Oracle Type 2 driver would use Oracle's OCI to communicate with the Oracle database while offering better performance than Type 1. It requires native library installations on the client machine, making it less portable. Then we have type 3, the network protocol driver, also known as the middleware driver. This driver uses a network protocol to convert JDBC calls into a database independent network protocol, which is then translated by a middleware server into the database specific protocol. This offers good portability and allows a single driver to access multiple databases through the middleware. Finally, the most commonly used or recommended driver today is Type 4, the thin driver, also known as the pure Java driver. This driver converts JDBC calls directly into the database specific network protocol, completely written in Java. This means no native libraries are required, making it highly portable, efficient, and suitable for web applications. It communicates directly with the database, bypassing any middleware or ODBC layers. Understanding those types is a key of choosing the right connectivity solution for your application. Choosing the right driver. With your four different types of JDBC drivers available, choosing the right one for your project is a critical decision that can significantly impact your application's performance, portability, and overall compatibility. There is no one size fits all answer, as the best choice largely depends on several key factors. Primarily, you need to consider the specific database you are connecting to, and equally important, the environment in which your Java application will operate. For instance, if you are developing a modern web application and connecting to JDBC complaint database like MySQL, a Type 4 driver is almost always the preferred choice. This is because Type 4 drivers are entirely written in Java, offering excellent performance and maximum portability. As they don't require any native library installation, they communicate directly with the database, simplifying deployment and management. However, Type 1 driver might be a temporary solution though it comes with performance drawbacks. Similarly, Type 2 drivers may be considered if you need to a specific database features accessible only through native applications and are willing to sacrifice some portabilities. Type 3 drivers are useful for complex enterprise scenarios involving middleware. Always evaluate your project specific requirements before making your final decision. JDBC packages. When working with JDBC, you will primarily interact with classes and interfaces found within two core Java packages, java.sql and javax.sql. Those packages form the backbone of the JDBC application, providing all the necessary components for database interaction. The java.sql package is the foundational JDBC application. It contains the essential interfaces and classes that most developers will use for basic database operations. Key interfaces here include driver, which manages database drivers, driver manager responsible for managing connections to databases, connection representing an active connection to a database, statement used for executing static SQL statements, prepare statements for pre-compiled SQL statements, and result set which holds the data retrieved from a database query. You will also find classes for handling different SQL data types like date, time, and timestamp. The javax.sql package, often referred to as the JDBC optional package application, provides advanced features and capabilities. It's particularly useful for enterprise level applications, offering features like connection polling and distributed transactions. Important interfaces in javax.sql include data source, which is the preferred way to get database connections in application servers, and row set, which provides a powerful and flexible way to work with tabular data retrieved from a database. While java.sql provides the core functionality, javaxsql enhances it for more scalable applications. Core JDBC interfaces. To truly understand how JDBC works, it's essential to grasp the role of its core interfaces. Those interfaces define the contracts for interacting with database functionalities. First, we have the driver interface. This interface is implemented by JDBC drivers provided by database vendors. It's responsible for managing the actual database communication, translating JDBC calls into the specific protocol understood by the database. While you rarely directly interact with the driver interface, it's critical underlying component. Next is the connection interface. This is one of the most important interfaces in JDBC. A connection object represents a unique session with a specific database. All SQL statements are executed within the context of a connection. It allows you to manage transactions, set auto commit modes, and retrieve metadata about the database. The statement interface is used for executing static SQL statements. You will use to send SQL commands to the database. For more dynamic or frequently executed queries, prepared statements is a more efficient and secure alternative, which we will discuss shortly. After executing a SQL query, the results are encapsulated in a result set object. This interface provides methods to navigate through the retrieved data row by row and column by column, allowing you to extract the information you needed. Finally, SQL exception is the exception class for handling errors that occurs during database operations. It's crucial for error handling in your JDBC applications. Understanding those five core interfaces is fundamental to effective JDBC program. Loading the driver. The very first step in establishing a database connection with JDBC is to load the appropriate JDBC driver. This process makes the driver available to your Java application so that the driver manager can locate and use it. The standard way to load a JDBC driver is by using the class.forName method. As you can see in example code, class.forName method dynamically loads the specified driver class into the JVM. When the driver class is loaded, it automatically registers itself with the driver manager. This registration is what allows the driver manager to identify and manage the various database drivers that your application may need to interact with. It's important to note that the specific string you pass to class.forName method depends on the database you are connecting to. For instance, for MySQL, typically use com.mysql.cj.jdbc.driver. You are working with Oracle, it would be oracle.jdbc.driver.oracle driver. The correct driver class name is always provided by the database vendor, so it's essential to consult their documentation. It's also good practice to wrap this call in a try-catch block to handle class not found exception, ensuring your application gracefully manages situations where the driver is not found. Establishing a connection. Once the JDBC driver is loaded, the next crucial step is to establish a connection to your database. This connection acts as the communication channel between your Java application and the database server. You achieve this using the driver manager.getConnection connection method. The get connection method is overloaded, meaning it has several variations, but typically you will provide three pieces of information: the database URL, your database username, and your database password. The URL is a special formatted string that tells JDBC where to find the database and what type of database it is. When get connection method is called, the driver manager attempts to find a suitable driver from its registered drivers that understands the provided URL. If a matching driver is found, it uses that driver to establishing a physical connection to the database. This method returns a connection object, which is your gateway to performing all subsequent database operations, such as creating statements, executing queries, and managing transactions. It's to handle potential SQL exception during this process, as connection failures are common if credentials, URL, or database availability issues arise. This connection object so efficient management and timely closure application performance and scalability. Connection URL format. The database connection URL is a special formatted that JDBC uses to identify and locate the database you want to connect to. It's essentially the address for your database telling JDBC what driver to use, where the database resides, and which specific database instance or schema to connect to. Let's break down the typical format as shown on this slide. JDBC. This is the universal prefix for all JDBC URLs, indicating that is a JDBC connection. Subprotocol. This part specifies the particular JDBC driver that will be handle the connection. For example, MySQL for MySQL databases, Oracle for Oracle, and so on. This portion maps directly to the type 4 driver. Host. This is the network address or host name where your database server is running. Often for local development, this will be localhost. Port. This is the specific TCP or IP port number that the database server is listening on for incoming connections. Database name. Finally, this is the name of the specific database or schema within the database server that you want to connect to and interact with. So, a complete example clearly instructs JDBC to use the MySQL driver connected to a database on the local machine at port 3306 and specifically targeted the database named your database name. Understanding this format is key to correctly configuring your database connections. Creating statement object. Once you have a live connection object to your database, the next logical step is to create a statement object. This statement object is what you will use to execute SQL queries and commands against the database. There are primarily two ways to create a statement object from your connection: using create statement method and prepare statement method. The create statement method part of the connection interface creates a basic statement object that allows you to execute static SQL queries. This means the entire SQL query string is passed at the time of execution, and it's generally suitable for SQL commands that do not change the executed only once. However, for most practical applications, especially those dealing with user input or frequently executed queries, prepared statement is the preferred method. As the diagram prepared statement is a subinterface of statement. A prepared statement object is created with a SQL query that contains parameter placeholders, typically represented by question mark. This precompiles the SQL query on the database side, offering significant performance benefits for repeated executions and crucially providing robust protection against SQL injection attacks, which we will discuss in more detail. There are also callable statement, which extends prepared statement used specifically for executing stored procedure in the database. While all three allow SQL execution, choosing between statement and prepared statement is a fundamental decision based on your query's nature and security consideration. Executing SQL queries. After creating a statement or prepared statement object, the next step is to execute your SQL queries against the database. JDBC provides specific methods for different types of SQL operations. For retrieving data from the database which involves select statement, you will use the execute query method. This method returns a result set object which contains the data retrieved from your query. We explore result set in more detail on the next slide, but essentially it allows you to iterate through the rows and columns of your query's results. For SQL commands that modify the database such as insert, update or delete statements, you will use the execute update method. Unlike executed query, executed update returns an integer value which typically represents the number of rows affected by the SQL operation. This is useful for confirming whether your data modification was successfully and how many records were impacted. As the slide highlights, there are primarily two approaches to executing SQL queries. Using statement. This is suitable for simple one-time SQL queries. Using prepared statement. This is highly recommended for queries that are executed multiple times or involves dynamical parameters, offering better performance and crucial security against SQL injection. We will deeper into prepared statement soon. Understanding when to use execute query and execute update and the difference between statement and prepared statement is fundamental to effective JDBC program. Using result set. The result set interface is a cornerstone of data retrieval in JDBC. When you execute a select query using execute query method, the data returned by the database is encapsulated with a result set object. Think of it as a cursor pointing to a table of data, allowing you to navigate through the rows and extract the information you need. Here a typical implementation flow for using result set. First, within your Java project, you will set up your connection to the database. This usually involves loading the JDBC driver and then establishing the connection. For example, with a MySQL database using the MySQL connector.jar file. Once connected, ensure you have a table in your database populated with some data for querying. Next, you will write an SQL query. To retrieve data from this table, it's often best practice to use a prepared statement for this, especially if your query involves dynamic parameters. After creating your prepared statement object, you will call its execute query method. This sends your SQL query to the database. If successfully, the database executes the query and returns the results. Those results are then assigned to a result set object. You can then use methods like next method to move to the next row and get in methods to extract data from specific columns by name or index. The result set provides a powerful and flexible way to process query results programmatically. Inserting data. Now let's move on to one of the fundamental create, read, update, delete operations. Inserting data into your database with JDBC. You can easily add new records to your tables using SQL insert statements. When inserting data, you will typically use a statement or prepared statement object and call the execute update method. Remember, execute update is used for DML, extends data manipulation language, operations that modify the database and returns the number of rows affected. For secure data insertion, especially when dealing with variable data, it is highly recommended to use prepared statement with parameter placeholders. This not only prevents SQL injection but also offers performance benefits by pre-compiling the query. We will deeper into prepared statements for various operations including inserts in upcoming slides. The key takeaway here is the execute update is your go-to method for adding new rows to your database tables. Updating and deleting. Beyond insertion new data, JDBC also provides that means to modify existing records and remove them from your database. Those are the update and delete operations in create, read, update, delete, and just look like within insertions. The execute update method is your primary tool for those tasks. To update existing data, you will construct an SQL update statement. This statement specifies which table to modify, the new values for specific columns, and a where clause to identify the exact rows you want to change. For example, update products set price equals to 25.00, where ID equals to 101. Would update the price of a product with a specific ID. You would then pass this SQL string to statement.execute update. The returned integer would indicate how many rows had their price updated. Similarly, for deleting data, you will formulate an SQL delete statement. This statement specifies the table from which to remove rows and critically a where clause to filter which rows to delete. For instance, delete from customers where status equals to inactive would remove all inactive customer records. Executing this with the statement.execute update would return the count of deleted rows. It's crucially to always include a where clause in your update and delete statements unless you intentionally want to modify or delete all records in a table, which is a rare and potentially dangerous operation. For safety and efficiency, especially with dynamic conditions, prepared statement is highly recommended for update and delete operations, allowing you to set parameters securely and prevent SQL injection. Prepared statement introduction. While the statement interface is useful for simple one of SQL queries, the prepared statement interface is a far more powerful, secure, and efficient alternative, especially for repeated queries or those involving user input. At its core, a prepared statement is an SQL statement that has been pre-compiled by the database. It's a sub-interface of statement inheriting its basic functionality but adding significant enhancements. Instead of concatenating variables directly into your SQL string, prepared statement allows you to define SQL queries with parameter placeholders, typically represented by question mark. This concept of parameterized queries is central to its advantages. Let's look at the key benefits. Firstly, when a prepared statement is created, the SQL query is passed as a parameter and the database compiles this query just once. Subsequent executions of the same prepared statement can then simply run the pre-compiled query, leading to much better performance, particularly for frequently executed operations. Secondly, you can reuse the same prepared statement object and supply different parameters each time it's executed, making your code more flexible and reusable. But perhaps the most critical advantage is its role in preventing SQL injection attacks. By using placeholders, prepared statement automatically handles escaping especially characters. ensuring that input is treated as data, not as executable SQL code. This makes your applications significantly more secure against a very common type of. For any non-trivial database interaction, prepared statement should always be your go-to choice. Using prepared statement. Let's walk through the fundamental steps to effectively use prepared statement in your JDBC applications. It is a straightforward process that significantly enhances the security and performance of your database interactions. Step 1. Create connection to database. As with any JDBC operation, the very first step is to establish a connection to your database. Step 2. Prepared statement. This is where prepared statement differs from a regular statement. Step 3. Set parameter values. Before executing the query, you must set the values for each of the parameter placeholders. Executing prepared statements. Building on the previous slide, let's visualize the complete flow of executing prepared statements and deeper into how parameters are bound. The flowchart clearly outlines the life cycle. First one, establishing the connection. As always, the process begins by obtaining a connection to your database. Second one, creating. Prepared statement object. Next, you prepare your parameterized SQL query and use connection.prepare statement to create the prepared statement object. Binding of parameters. This is where the power of prepared statement truly shines. Submitting the SQL statements. Once all parameters are set, you executed the prepared statement. Processing the results. If it's a select query, you then process the result set to extract your data. Looping for more statements. The beauty of prepared statement is that you can loop back and bind new parameters to the same prepared statement object for repeated executions without recompiling the query. Closing prepared statement and connection. Finally and crucially for resources management, you close the prepared statement and then the connection when you are finished with them. This releases database resources and prevents leaks. This structured approach ensures efficient and secure database interactions. Batch processing. When you need to execute a large number of SQL statements, especially insert, update, or delete operations, one by one, it can be inefficient due to the overhead of network communication and database processing for each individual statement. This is where JDBC batch processing comes into play, offering a significant performance improvement. Batch processing allows you to group multiple SQL statements together and send them to the database as a single unit. The database then processes this entire batch more efficiently, reducing network round trips and optimizing execution. You typically use a prepared statement for batch processing because of its ability to set parameters for multiple insertions or updates with the same SQL query structure. The core methods for batch processing are add batch method and execute batch method. First, after preparing your prepared statement, you will set the parameters for the first operation and then call prepared statement dot add batch. This adds the current set of parameters and the SQL statement to an internal batch queue. You repeat this process for all the operations you want to include in the batch. Once all statements are added to the batch, you call prepared statement dot execute batch. This sends all the queued statements to the database for execution. The execute batch method returns an array of integers where each integer indicates the number of rows affected by the corresponding statement in the batch. This approach is particularly scenarios like mass updates where the reduction in communication overhead translates directly into faster application performance. Transactions. Transactions are a fundamental concept in database management, crucial for maintaining data integrity and consistency, especially when multiple related operations needed to succeed or fail as a single atomic unit. In JDBC, transactions provide this control. By default, JDBC operates in auto commit mode, meaning every SQL statement is treated as a separate transaction and is automatically committed to the database immediately after execution. However, for operations that involve multiple steps where all steps must complete successfully or none at all, you need to manage transactions manually. This tells JDBC to collect a series of SQL statements into a single transaction. As the diagram, a transaction treats as a single SQL statement or a group of SQL statements as a logical unit. If all statements within this unit execute successfully, you call commit method to make the changes permanent. If any statement within the transaction fails or if an error occurs, you can call connection.rollback. The rollback method undoes all changes made since the last commit or since the transaction began, restoring the database to its state prior to the transaction. This ensures that your database remains in a consistent state even in the face of errors, preventing partial updates and maintaining data integrity. Save points. While full transaction rollback undoes all changes since the start of transaction, JDBC also offers a more control mechanism through save points. Think of a save point as a marker within a longer transaction, allowing you to partially roll back changes to a specific point without discarding the entire transaction. This is particularly useful in complex scenarios where you might perform several independent operations within a single transaction. If a problem occurred during a later operation, you don't necessarily want to undo all the successful operations that preceded it. Instead, you can roll back to a previously established save point, effectively undoing only the changes made after the save point was set. You create a save point object by calling the connection.setSavePoint method on your connection object. This method returns a save point object which represents the state of the database at that exact moment within the transaction. If you later encounter an error or decide to reverse some operations, you can call connection.rollback save point. Passing the save point object, this will revert the database to the state it was in when that particular save point was created, while preserving any changes made before it. Save points are an advanced but powerful tool for fine-tuning transaction management in your JDBC applications, providing more flexibility in error recovery and partial transaction reversals. Handling exceptions. Robust applications development always includes proper error handling, and JDBC is no exception. When interacting with databases, various issues can arise, such as network problems, invalid SQL queries, database servers downtimes. JDBC exception handling allows you to gracefully manage those exceptional conditions. The core principle remains the same as general Java exception handling. You use try-catch blocks. When an exceptional condition occurs during a database operation, a SQL exception is thrown. The term thrown means that the normal flow of program execution is interrupted and control is transferred to the nearest catch block that can handle that specific type of exception. The most common exception you will encounter in JDBC is java.sql.sql exception. This exception provides detailed information about the error, including an error message, a SQL state code, and a vendor-specific error code. This information is invaluable for debugging and understanding what went wrong. It's crucial to always wrap your JDBC code, especially connection statement execution and result set processing, within try-catch blocks to catch SQL exception. Additionally, it's best practice to ensure that the database resources like connection, statement, and result set are always closed in a final block, regardless of whether an exception occurred to prevent resources leaks. Metadata. Beyond simply interacting with the data itself, JDBC provides powerful capabilities to retrieve metadata, that is, data about the data, from your database and its query results. This functionality is exposed through two key interfaces: database metadata and result set metadata. The database metadata interface allows you to query information about the database system itself. It's an incredible rich interface providing methods to discover various aspects of the connected database, such as its name, version, and the version of the JDBC driver being used. Information about the database structure, including details about tables, columns, primary keys, foreign keys, and indices. The SQL syntax supported by the database, its capabilities, and generally details about database objects. You obtain a database metadata object from your connection object by calling connection.getMetadata. This is invaluable for building generic database tools or for adapting your application's behavior based on the specific database it's connected to. On the other hand, result set metadata provides information about the structure of a specific result set. This includes details like the number of columns, the names of the columns, their data types, and their precision. You obtain a result set metadata object from a result set object by calling resultSet.getMetadata. This is particularly useful when you need to process query results dynamically without prior knowledge of the column structure, such as an reporting tools. Scrollable result set. By default, when you execute a select query and obtain a result set in JDBC, it's typically forward only. This means you can only move from the first row to the last using result set dot next. Once you have moved past a row, you cannot go back to it without re-executing the query. However, for certain applications, you might need to navigate the results in a more flexible manner. This is where scrollable result sets come into play. Scrollable result sets allows you to move the cursor both forwards and backwards, jump to specific rows, or even move relative to the current position. To create a scrollable result set, you need to specify its type when creating your statement or prepared statement object. There are two primary types of scrollable result set. First one, result set dot type dot scroll dot insensitive. This type of result set is insensitive to changes made to the underlying data while the result set is open. Second one, result set dot type dot scrolls dot sensitive. In contrast, a sensitive result set will reflect changes made to the underlying data by other transactions while your result set is open. To specify those types, typically pass them as arguments when creating your statement or prepared statement. Updatable result set. In addition to being able to scroll through results, JDBC offers the powerful capability of an updatable result set. This feature allows you to directly modify the data within the result set itself, and those changes can then be pushed back to underlying database. When you create an updatable result set, you are essentially getting a live view of the database rows. You can navigate to a specific row, make changes to its column values using setter methods like update string, update int, etc., and then call result set dot update row to persist those changes back to the database. Similarly, you can insert new rows using results dot move to insert row, followed by update row or delete row using result set dot delete row. They are particularly relevant in scenarios where you are processing a large number of records in a batch, perhaps needing to modify several fields on each record processed and then efficiently committing those changes back to the database. In an enterprise environment, their most practical applications often lies within large-scale batch processing, where the overhead of individual updates would be prohibitive. Most transactional web applications direct update and delete SQL statements are useful, preferred due to clearly separation of concerns and similarly error handling. Connection pooling. In high performance or web applications, constantly opening and closing new physical database connections for every request can be significant performance bottleneck. Establishing a database connection is a resources intensive and time consuming operation. This is where connection pooling becomes indispensable. A JDBC connection pool is essentially a managed group of reusable database connections. Instead of you create a brand new connection every time your application needs to talk the database. This mechanism dramatically improves application performance and scalability by reducing the overhead of connection creation and destruction. It allows helps in managing database resources more efficiently, preventing issues like connection exhaustion. Connection pooling is a standard practice in enterprise Java applications, especially those deployed in application servers like Tomcat, JBoss, or WebLogic, which provide their own robust connection pool implementations. JDBC best practices. To ensure your JDBC applications are efficient and secure, adhering to a few best practices is crucial. Those guidelines will help you write highly quality database interaction code. Firstly, always close your connection statements or result sets. Secondly, prioritize using prepared statement over statement for executing SQL queries. Lastly, for any application that experiences moderate to high traffic, implement connection pooling. Conclusion. That brings us to the conclusion of your rough overview of Java Database Connectivity or JDBC. We have covered a lot of ground today, from understanding what JDBC is and its fundamental architecture to exploring different driver types, core interfaces, and essentially operations like create, read, update, delete transactions, and batch processing. We all touched open crucial topics like handling exceptions, retrieving metadata, and the importance of scrollable and updatable result sets and connection pooling. Thank you for joining us on Study Recnos Tech Tutorials. We hope this session has provided you with a strong foundation in JDBC. Don't forget to like, share, and subscribe for more tech tutorials. Happy coding and see you in the next video.